What is correlative conformity in geology? In geology, correlative conformity is a term used to describe a boundary between two rock formations that appear to be in conformity with each other, suggesting that they were formed at the same time or under similar environmental conditions. This term is often used in stratigraphy, which is the study of rock layers and how they relate to each other. Correlative conformity indicates that the two rock formations on either side of the boundary were deposited under similar environmental conditions, but with some time gap between them. This means that they may have been separated by a period of erosion or non-deposition. It is important to note that correlative conformity is not necessarily evidence that the two formations are of the same age. In fact, they may be of different ages, but the boundary between them appears to be conformable due to the similarity in the depositional environment. How correlative conformity are formed? Correlative conformity in geology are formed when two adjacent rock formations appear to be conformable or in a continuous sequence without any visible signs of interruption or unconformity. The formation of correlative conformity requires that the two rock formations were deposited under similar environmental conditions, but with a time gap between them. For example, let's say that a layer of sandstone is deposited on top of a layer of shale. If the two layers are conformable, without any significant change in sediment composition or deformation between them, it suggests that they were deposited in a continuous sequence under similar environmental conditions. This may indicate that the shale layer was deposited first and later covered by the sandstone layer, with a period of erosion or non-deposition in between the two events. The formation of correlative conformity is often determined through detailed field observations, geological mapping, and analysis of sedimentary structures, fossils, and other geological features. By understanding the depositional history of a region, geologists can interpret the geological processes that have shaped the Earth's surface over time. What are the importance of correlative conformity in sequence stratigraphy? Correlative conformity is an important concept in sequence stratigraphy, which is the study of how sedimentary rocks are arranged in time and space. Sequence stratigraphy aims to understand the processes that control the deposition of sedimentary rocks and to reconstruct the evolution of sedimentary basins. The importance of correlative conformity in sequence stratigraphy can be summarized as follows. Identification of depositional sequences. Correlative conformity can be used to identify the boundaries between depositional sequences, which are packages of sedimentary rocks that were deposited in a specific order and under specific environmental conditions. By identifying the correlative conformity, geologists can determine the boundaries between depositional sequences and interpret the depositional history of the basin. Recognition of time gaps. Correlative conformity can also help identify time gaps or hiatuses in the sedimentary record. These gaps may result from erosion, non-deposition, or other processes that interrupt sediment accumulation. The recognition of time gaps is important for understanding the temporal evolution of sedimentary basins and for reconstructing the history of environmental change. Stratigraphic correlation. Correlative conformity is also important for stratigraphic correlation, which is the process of linking rock units from one location to another based on their stratigraphic characteristics. By recognizing correlative conformity, geologists can correlate rock units from different locations and build a regional stratigraphic framework. Prediction of reservoir quality. Correlative conformity can also provide insights into the lateral and vertical continuity of reservoir rocks. The recognition of correlative conformity can help predict the distribution and quality of reservoir rocks, which is important for the exploration and production of hydrocarbons. In summary, correlative conformity is a fundamental concept in sequence stratigraphy that helps geologists interpret the depositional history of sedimentary basins, identify time gaps in the sedimentary record, correlate rock units, and predict reservoir quality. Please don't forget to subscribe to my channel and turn on notifications.